Good morning, everybody, to the training, how to use the federated query system of the Swiss Personalized Health Network. My name is Katrin Kramery. I'm heading the Personalized Health Informatics Group at SIB. And with me in this call is Sabine Oesterle, our team lead for data interoperability at the FI Group. And she put this training together for you, and she will also guide you through the training. Please allow me some words of introduction to it, because we have probably a lot of people in the call who are not very familiar with SPHN and the work that we are doing here at the FI Group. We are running the SPHN Data Coordination Center and also the Biomed IT project. And with our duties in the realm of the Data Coordination Center, we help the hospitals to set up this federated query system in the last years. For the reason of our mandate, basically, that we got from the SERI to support personalized health research and personalized health care ultimately in Switzerland. So SPHN is a research infrastructure initiative. And in order to come to this point that we can realize personalized healthcare in Switzerland, a lot of different measures are needed to be implemented, and this is actually what we try to support from the FI Group side. I think we can all agree that given the vast amount of health data currently available in the healthcare setting, maybe human beings are the best characterized model organism in biology so far. The healthcare decisions should not longer be based on population averages, but should take into account individual patient characteristics. So how do we get to this, right? Personalized to realize personalized health. We need to bring together a lot of information from a lot of patients and maybe also healthy citizens in order to be able to run those big data studies that allow access to large amounts of data, to do data mining, data exploration, and find new correlations, new signals, and new associations in order to come up with new hypotheses that, of course, then need to be tested in regular controlled clinical trials or other measures in order to finally lead to the goal of SPHN and other initiatives in the same manner to receive more precision diagnostics, prevention, prediction, and treatments possibilities to improve quality of care overall, and of course to reach that well-desired learning health system that I think we all are dreaming of. In order to be able to also add to those clinical or phenotypical data the biological body to it. Next slide, please. Our sister initiative of the Personalized Health and Related Technologies of the ETH domain put up 3 clinical analysis centers for genomics, proteotype and proteomics and metabolomics, lipidomics in the ETH domain, to help researchers to come up with these biological layers for personalized health, where you have the genomics, epidemiologics, transcriptomics, proteomics, whatever omics layer you can think of. And on top, ideally, goes the phenotypic data that in SPHN is recruited through the university to the 5 university hospitals in order to make this data integration possible and to find those new correlations, those signals that we can then translate into new diagnostics or therapies, ideally at the end. Next slide, please. So SPHN is a large network launched in 2017 with 8 years of running time and 135 million francs dedicated from the ERI dispatch of the Parliament and guided by the State Secretariat for Research, Innovation and Education. The goal is to create a scalable and sustainable data enabling environment, so a health data ecosystem, but a federated health data ecosystem, so a decentralized one, right? We are always aiming for a decentralized architecture. We want data to be of high quality coming out of the sources where it's actually captured, and then particularly taking it together in individual research projects, but keeping the data federated at the source. The goal is finally to enable institutions like hospitals to responsibly share interoperable health data and enable researchers to responsibly access and integrate and analyze the data. Next slide, please. And just before I give the word to Sabine, what we did now with the university hospitals, with a lot of efforts that are put into this on the university hospital side, is putting up data platforms that basically collect the data. When you look at the journey of a patient through a hospital, all of the data is basically stored in primary sources, right? In source systems that are not connected, that you cannot query all together. So basically there is, next slide please, there is the complex work of data integration from those different heterogeneous sources, and of course also the implementation of standards and mappings to terminologies according to the SPHN interoperability strategy, in order to receive data collections in data management systems or clinical data warehouses, or further in the process, clinical data lakes, where you have all of the data together for secondary use. Next slide, please, Sabine. Exactly, with the standards, with the codes, with the according to data specifications. And this is the basis that we needed to be able to build such a system as the federated query system, because the data to the federated query system comes out of those clinical data warehouses. So this was all introduction from my side. Sabine, I give the word to you now. Thank you very much for putting together this training.
Thanks a lot, Katrin, for that introduction and setting the federated query system in the context of SPHN. So I think now we will start with that training. I think you have seen we have a huge amount of participants. So of course, I'm very happy for that. However, actually, I think in that way, I'm shifting the training a bit to have more like a demo and then a kind of question session at the end, because I think with 90 people doing an interactive online session is, I think, quite a challenge. So I would like to ask you to put your questions in the chat, and we can actually at the end of the session answer them. Also, if we have some time, I would also suggest we can do maybe some individual queries, which you are already interested, try it out. So for the topic of today, I think the first thing will be, again, a few slides where I give you some background of the system. And then actually we will switch to the application. So actually we do kind of live demo where I show you the different kind of functionalities to set up such a query. Also, the slides will be shared afterwards. So also I have always the slides prepared, which have some screenshots of things I will be doing in the interface directly, but also that for later reference, you have the kind of steps you need to do certain functionalities. So with that, maybe the first more important one, how can I get access to the system? I know that some of you already registered and have already your account. Some did not have the time to do that. This is completely okay. So this is again the thing, you can just follow my demo and do it afterwards by yourself, repeat it. Or if you like, you can log into the system and do the same steps I do in the system with me. But again, this is not necessary. So if you want to get the access after this training, then actually what is important is that we base all of that on the Switch EduID with an AAI link. This is very important so that we know to which institutions do you belong, because as you know, we are really having contracts with each institutions for the use of this federated query system. So the Switch EduID is your national identity, and with the AAI link, we can link that to the institutions. And of course, we have here instructions how to do that, and also you can contact our help desk if you encounter here any problems. For the registration of the federated query system, this is going through our Biomed IT portal. So again, here is the link. Important thing is that you need to sign and accept our use policy. Just make sure that you only use the system for what it is intended to use. You not try to re-identify patients. Also, you not try to do any other criminal things with the system. So have a careful read through it and then accept it and also follow it. Again, here you find then the instructions of the different steps in the portal, how to register. You will then, after you finish this registration, within 24 hours, you will actually get your account details for the system. And please be aware that we use a second factor authentication with your institutional email address. This is very important to make sure that you have still access to this email address, because that is a proxy for you still being at this institution. So again, I think this is more for the record, for later for you to do the steps to get the account. Let's now dive into what is the Federated Query System about. So it's actually a system made for feasibility queries. So it's actually, as Katrin said, it's really to explore what kind of patients or what kind of data is available in the clinical data warehouses, which could be used for your research project. That being said, is that in the Federated Query System, we are only including data from patients with signed the general consent. So this means that this is data which is really directly available for the research projects. Also, as we said, data stays within the hospital. So it's a system which is the new data is uploaded once a month into the local instances at the hospitals, and is only the aggregated results of the queries are actually given to the users and to the central user interface. You can see here on the right such a kind of query example, which we also later will do. So you can, for example, an age, a gender, a diagnosis, medication lab test, and the result is that in this case, 100 patients actually are available at the 5 university hospitals following these criteria. And of course, this gives a very good idea to optimize also study protocols. So how many sites do I need to include? When do I get enough data for actually my research project? Yeah, I think I mentioned that here also with this example query. So what we have is the age and the gender. We have the diagnoses. We have the procedures. We have the lab tests with their results. And we have the prescribed medication in the system. So how many patients are there in Switzerland in this system, which, as I said, are people who signed the general consent? So in total, we have now more than 500,000 persons in the system. And you can see here we started including patients which had a visit starting from 2015. And I think what you can see here is really that the numbers are rising by year. And this is really due also to the fact that we more and more have the procedures established to show patients the general consent and actually get that signed. So actually this increase here is really also related to the consent. It's not the consent rates, but the amount of people seeing the consent. Yeah. And for the data, also some facts here. So in total, we have over 125 million data elements in the system. And these, as I said, are consisting out of the large majority is lab tests. And here, actually, what I have to say is that all of these lab tests are coded in LOINC. And as you know, there is a lot of different lab tests available. So really keep here in mind that we are really within SPHN still in the process of introducing LOINC in the hospital. So even though this is really the largest percentage of data, there's still some hospitals which may not have all the data of the labs coded in LOINC. So it's also why sometimes if you put a LOINC code in, you will only get results from one hospital, which means that also here the coding efforts are not at the same rate at all the hospitals. But this is something which will, of course, improve over time. We then have the procedures. They are coded in CHOP. So for those of you who are aware, this is a standard, it's a Swiss standard for procedure. And yeah, more or less all patients, all inpatients actually had a procedure while they were normally at the hospital. The same then all inpatients normally get a diagnosis also for the billing purposes, which is coded in ICD-10 GM. So that's the two standards we use for procedures and diagnosis. And then we have medications. Medications we represent in ATC. So this is like the standard, which is not on the medication, on the product level, but more on the kind of substance level. So for example, did the patient get ibuprofen or paracetamol? The standard here. Also something which we have newly included. So again, we are in the pilot phase for that one, is the substance amount. So what's the amounts, for example, of ibuprofen a patient get? As I said, this is still in beta, so there is maybe still some issues with that, but this is something which we are heavily working on currently. So what can you search? You can do inclusion or exclusion. So you can say, I want a patient who had this diagnosis or which did not have that diagnosis. So if you're a bit familiar with the standards, so ICD-10 or CHOP, also ATC, LOINC, they are hierarchical standards. So you can either search for the codes itself. So example, type 1 diabetes mellitus with coma dereference as derailed, which is E10.01. So it's a very specific code. Or you can actually use the code groups. So you can go up the hierarchies. So for example, in this case that you only say, I'm interested in everyone who had diabetes or everyone who had diabetes type 1. So you can see here, I put a screenshot of the ICD-10. So you can actually search on all these different granularity levels. You can link things with and or statements. So we will later have a few examples because sometimes I've seen users where this is very confusing. So you can say the patient should have this diagnosis, this medication, and this lab result. Or for example, you can say, I want that the patient has either diabetes type 1 or diabetes type 2. And then it's actually creating the sum of both cohorts with the or linking. This becomes very important when we search for the LOINCs. We'll show that later in an example. The next thing which we can do is value constraints. So this becomes very important, of course, for the lab results, because you can imagine you don't only want to know if glucose was measured, as the glucose in blood was measured for that patient, but you want to know, was it higher than a certain threshold? Was it within a certain range? So these are the kind of value restrictions you can set. And as I said, we can do this for the lab results. And newly, we also can do this, of course, for the substance amounts. So for example, I want only patients which got more than 300 milligrams of ibuprofen. We can do temporal constraints. So as I said, we included patients from 2015, but as you also have seen in the beginning, the consent, there's not so many people included due to the lower consent rates. So maybe you only want to know in the last year how many patients were included there. So you can also set this kind of time restrictions to search, or maybe also, there is always the flu season, so you only want to search in the autumn or the winter time. So this is really done on a really day by day level where you can set this temporal constraints. So how does result look like? As we said, it's a federated query system. So it actually gives you aggregated numbers. So it will present you with results. So actually saying, for example, here you can see this is how many patients we have in total in the system. So this is what I said, a bit more than half a million patients. And for this query, which I did here, which actually I don't remember which one, oh, it's the one here on the right, we have 489 patients which fulfill that criteria. And you can also see the numbers for the different hospitals, so how many patients you have with these characteristics. This is, of course, a very limited result. So maybe you want to know a bit more. And what can we reveal without actually revealing too much, let's say, because we want, of course, to ensure the privacy of the individual patient. I will come to that on the next slide. But we can also here look at this kind of funnel. So we can see here our different criteria, and we see how our population cohort is narrowing down. So here we first have only the age, or we have the total patients. Then we have the age restriction, with the restriction on that they should have this diagnosis, then they should get certain medication, and so on. And you can see here that in total this boils down to this around 500 patients, which 321 are male and 168 are female. So as I mentioned, data protection is really important. So this is really, as I said also before, the data stays within the university hospital, and only these aggregated results are actually exposed via the web interface. And yeah, we have some summary statistics also on individual parameters, but as I said, always within this limit of not being able to re-identify the single patient. And this is also why if you really start to drill down very specific criteria, as soon as you have less than 10 patients which have this criteria, then actually the results will not be displayed by a number, but it will only tell you there is less than 10 patients available which have this criteria. And of course, this is also due to the fact if there is only 5 patients, then yeah, most often this would not have also the statistical power to do then a kind of data analysis. So I think we really have here a good balance between data protection and also we are not limiting the usability here. So I think that was the theory. What I would like to do now, as I said, is go with you into the system directly and do some queries. As I said, I will always switch between the slides and the browser, so I hope this will go well, and always show you what I want to do, and then I will do it in the kind of web interface. So the first query we want to look at is a very simple one. So we will have inclusion and exclusion criteria. You can see here you have the inclusion criteria where we have again an age. It's the same example than before, the diabetes, and we wanted, there was a hemoglobin measurement taken by this patient. And actually as an exclusion criteria, we say again also a diagnosis that the patient should not have this kind of diagnosis. As said before, for lab results, of course, we want to also restrict the results. So this is something which you can see here. So whenever this kind of symbol is actually shown in your query, you can see that there was a quantity restriction set. And also I will show you when you hover over that in the system, it will tell you which one. So this is the first query we want to do, some simple inclusions, exclusion criteria, and this quantity restriction. So let me now find my browser on the other screen. Okay, so I'm logged out of the system. So let's quickly log in again. As I said, I'm not required to do the second factor because I was logged in already today. Normally you would now get asked for the second factor. So when you log in for the first time, you will come to this kind of page where there's actually, it's like a folder system where there is different folders with different queries, which other people in your institution have already done. And you can see here, I created already a folder for today's training. So I called it October 2022 FQS training. And also I had already 2 queries placed in here. But now, since we want to do this really from scratch, actually, I will really create the queries from scratch. So here I have this button here, add a new query, and I have add a new folder. So you can imagine if you want to be very structured, you can first create a folder and then as you normally do also in a file system, put then the queries in a different folder or put a folder in a folder and then put the query. But since I'm already in my right folder, I can say add new query. I will then, of course, ask for, I need to give my query a name. This being said, this needs to be a unique name, so you can very easily imagine that since I'm doing similar examples quite often, I'm having often a clash that the name exists. That's why I'm taking the date of today. And then so our first query is about diabetes. So I call that diabetes. There is more metadata which you can fill. You see that by the star, this is the two which are required. All others are optional, but sometimes if you also later want to remember what you've done, it can be very helpful to actually fill that, but it's not mandatory. You have, just move my picture away. You have always here the save and update button. So I have now put in the name. So I say save and update. Again, here, the next I can put, this is really metadata information, inclusion and exclusion criteria as a text. So you can really see, if I would type here something, I can really type everything in. Again, this is only for you to remember. So this is really free text, which helps you to remember what you want to do. So for my case, I keep that empty. So again, I say save and update. And then actually I'm at the query designer, how it's called. And actually the software already indicates me what to do next. So actually the next thing I do to continue coding the query, you have to select the sites. So I click here on select a site. And you can see here we have our 5 university hospitals which are connected to the system, which I can select. So I can choose if I only want, for example, to search in Insel and Hüg, or if I want to click all of them. And if I'm lazy, I'm just clicking here Switzerland, which then includes all the 5. As always, the disk, the floppy disk gets very important. So I say save and update. And then you see here it says successfully update. So we have now saved that we want to search in all 5 university hospitals. The X, as always, is to close the window. So I close it to go back here to my query. So what you can see here on the left is actually, we have this different, let's say, symbols here. And if I hover over it, it tells you like demographics, new diagnosis, new medication, new lab, and new procedure. So this is our search criteria. And what you can now do is you take, for example, the demographics and you drag and drop it, for example, into the inclusion criteria or into the exclusion criteria. I do it now for the inclusion criteria. And what happens now is this dialog opens where I can see some summary statistics about the demographics. So what we can see here, for example, is the age distribution of the data we have in the system. And also you see it in this bars, but also here on this pie chart, the distribution between females and male in the system. And what you can also see is we can here, actually it says here, no, age is not limited, meaning if we leave it like that, we would search for all age ranges. But if you can remember correctly, we said in this query, we are only interested in patient over 18 years. So you can take the slider bar and actually slide it here to the right. And now you see, now we are only searching for patients which are over 18 years. You could also, of course, slide the upper boundary, but for our queries, for our query now, this is not something we want to do. Also here with the radio button, I could search for only female or only male patients. And in our query, we said we are only interested in female patients. So I select female here. And then again, I go on add. It says here again, successfully added demographics. So I can close it. And now you see we have our first criteria in the system. So it's actually female and over 18 years old. The next thing we wanted to search for is the diabetes. So I take the diagnosis, again, drag and drop that into the inclusion criteria. And now what happens is it opens the terminology browser because we have coded all diagnoses in ICD-10. And I now here open the system, you can see that it shows you all the hospitals. This is due to the fact that in theory, actually the system could handle different terminologies in different sites, but to make it easy for you, we actually harmonize that and all hospitals are using the same standards. So what you can do here, you can actually, that's why it doesn't matter on which hospital I now click. You can open actually the terminology. And for those of you who are familiar with ICD-10, I think you will see that this is exactly the structure of ICD-10. And now to select my diabetes, I have actually two options. So either I actually know where I find it in ICD-10. So actually I know that diabetes is actually an endocrine, nutrient, and metabolic disease. So I can click here on the plus. And then you see it opens then the LOINC groups, where the second one is actually the group of diabetes mellitus. Again, I can click on plus here. And then you see actually the diabetes type 2, which I was interested in, is actually this code. And as I said before, you could also drill down even further. But as I said, for our query, we are only interested in patients which have diabetes type 2. And you can see here this target button. So that means this is the code I want to select. So if I click on that, you see it's displayed here on the right. I could now also select several of them. And if I'm happy with my selection, I can actually say add to query. Again, as similar than with the demographics before, we are now getting shown certain characteristics. So again, the age ranges for all the patients which have this diagnosis, and also as I said, the time ranges. So when was it recorded? I will tell you later how to do the time restrictions for this query. I keep it simple. So I close again this button, and you can now see that I have the type 2 diabetes mellitus in the system. I will delete it for now because I want to show you another way of adding it to it. You can see here there is the small little bin which says delete, so I delete it. And I do exactly the same. So I pull the diagnosis in. And actually this time I'm really lazy, so I don't want to go through the hierarchy knowing where in ICD-10 I find my code. So I can also just type here in the lexical search diabetes 2. I press enter for the search. Now you can see that it's actually say I have 2 results. So again, I open these ones. And now you see in a lexical search way, I get the kind of codes which have type 2 diabetes in the label. And again, I was interested in this E11. So I can again select the concept, add it to my query. As I said, see here the statistics. And that's actually resulting in the same way. So you have both options. Either you know where to search in the code systems. You can use the lexical search. If you would already know that the code you're looking is I11, you can also type that into the lexical search. Will all bring you to your right code. I then do the same for my lab analysis. So this was hemoglobin. It also is a bit tolerant to typos to some extent, but was here now again. I will have a short explanation on LOINC later and why you see so many different codes for you. Those of you who are familiar with LOINC, this is nothing new. For the others, as I said, I will say a few words later. But for my query now, to start simple, actually, I'm interested in this first line code 718-7. So again, I select it. I add it to my query. And as I said, it now opens again this kind of statistics. So if I'm now scrolling down, actually, I have the value distribution. And it looks like it needs some more time to load. Okay, on the right side, you would normally, yeah, now it's there. So you see the kind of value distribution of all the values which you have in the system. And again, here, similar as we had it for the age, we can now either use the slider, or we can actually also only type here our min and max values. So I'm interested in 130 to 180 grams per liter. So now you can also see that the sliders adjust. So now I'm only including patients which actually have exactly this results for the. So again, I go on save. I close the dialog. And the last thing which we had in my example query was the exclusion criteria of, again, a diagnosis. So do that quite short. This is an acute myocardial infection. So let's see if I find it without the infection. I was too lazy. So let's use the code. It's the I-21. So it's this one. I select the concept. I add it to my query. So this is how the query looked like. And you remember what I had on my screen, I think this exactly looks the same now. And now, of course, we would like to run that query. So here we take that guy here with the magnifying glasses, click on it, and then actually we come again to this page where we selected the different hospitals. And now the search starts. This is the demo effect. Normally, actually, searches go really within 10 seconds. A wise person said, never do live demos. Maybe I clicked the update. Maybe there was something wrong with initializing that. Yeah, I don't know. System didn't like me in the beginning. So you can now see the results are actually coming quite fast. So the different hospital systems are responding, and you can see the different numbers here. Zurich, for some reason, yeah, so Zurich is here. We had a lot of patients, so a big number to send. So you can see now that we have this 5,800 patients, which actually fulfilled our criteria. So there is a few things where, as I said, I showed you that you can see this funnel. So the funnel you can see when you click here on the actually our patients. So I click here on the funnel. You can actually see the funnel for this query now. So you can see actually by restricting the age criteria, I have still a lot of patients. And I then add the type 2 diabetes, actually my numbers go down quite a lot. And then I have actually the LOINC, which also goes down further. But here you can really see how the population gets smaller with each criteria which you include. Also, if you click here on your total number, you are actually able to see, for example, the age distribution of your population of choice. So you know, we selected patients over 18, so that's why we have no bars on the two lower age groups. And also you can see how this is different in the different hospitals. So you see there are some differences here. And also you will see that the ratio between female and male. But of course, since we've selected only female patients, yeah, we now see 100% females. Okay, so let me quickly switch back to my presentation. So I showed you how you can do the following query. As I said, this is just for you later when you look at the slides, how you set this quantity restrictions for the lab results. And now actually, let's do one other thing with the same query, which is a time restriction. So switching again back to the browser. So we said we want to have patients which are only diagnosed in a certain time window with this diabetes. So I select the diabetes type 2 criteria, and you can see here I have different options. So I could delete this criteria, I can copy it. I can set some time dependencies. I will come to that later. I can move it up or down in the query. It doesn't change the result, but it, for example, changes the way the funnel looks like. So you have seen my funnel really was from very large bars to very small ones. So by having the search criteria in different orders, the funnel can be also nicer. Or you can say edit. So we are, of course, interested in the editing, and we are actually interested in setting a time restriction. So you can either set a time restriction saying from today's date, you want to go back like a certain amount of days or months. But what I prefer is actually to use the time picker. So here I can really say from a certain date to a certain date. This is my inclusion criteria. And you can either type it or you can select it in this calendar function. So let's say we are interested in patients from the 1st of January 2021 to the last day of the year. So we would have exactly 1 year. So I would set it like this. I would press save. I close. And then again, I could run the query, start search. And now you can see that, of course, my results are smaller because I only selected a smaller time window to search. So again, this is how you set the time restriction, just for your reference later. Now let's have a short recap about LOINC. I don't know how many people of you are familiar with the standard LOINC. So LOINC is actually the standard we use in SPHN for describing the lab tests. So what kind of test was done. And I put you here one example. So for example, there's the LOINC code, which is this 43583-4. And this is actually for the lipoprotein in volumes per mole in serum and plasma. And you can already see that there is several pieces of information combined in such a LOINC code. And that's actually what is referred in LOINC to the axis. So we have actually 6 axes in LOINC, which is the component. In this example, it's the lipoprotein. We have the property, which is in this kind a substance concentration, because we have this moles per volume. We have a time aspect. So it's only, this is really a single measurement. So it's PT, to stand for time point. We have the system. The system is in which material mole, or in what's the system in which it was measured. So in this case, it's the serum or plasma. We have the scale. In this case, a quantitative measure. There can be also qualitative measures. There can be presences, so just like a yes or no. And then there is the method. You can see for this code, actually, there is no method. So that being said is that in LOINC, there is codes which encode the method and codes which are not encoding the method. And if you now do a search, what happens actually is that we can have different ways the same measurement is reported by the lab. So it can be either in like a substance concentration, as I said, moles per volume. So for example, millimole per liter, or it can be in a mass volume, which is indicated in the LOINC code here with this mass concentration. And of course, if we want to search we want to search, of course, for all patients with the lipoprotein. So we need to search for both codes. And also, if you, of course, want to apply somehow quantity restrictions, we actually need to do the kind of calculations from, if I know the kind of values I'm looking for in one unit, to actually also look with the molar masses, what is the restriction in the other units. And you can see here for this example, in moles per volume, actually we have 8 to 11 millimoles per liter, and that's actually around the same than the 130 to 180 grams per liter. If we now include that into a query, we need to connect the two statements by an OR connection. And this is very important because if I connect it with an OR connection, then I'm searching for patients which have either this LOINC code or the other code. If I'm doing it, connecting it with an AND connection, I'm looking for patients which have both. So having a result in grams per liter and moles per liter. And you can, of course, imagine, since it's often the case that it's different hospitals on different labs using different units, there will be, and actually I did this test here for this example. It's really, it gives you 0 patients because you are just searching for both criteria. So very important. If you get 0 patients, then really check if some of your connectivity statements actually should not be actually OR instead of AND. Now let's actually have a look how this is done in the system. So let's go back. So I close that one. And as I said, I will start a new query. So you can always, when you go here on this the symbol back to the list of queries, I'm now back to the list of queries, so I can add a new query. So as before, I call it with the date of today. 10/19. And this one is about the disease we are interested in. For that one is the atherosclerosis. This. I save. Again, I select the sites. To do that for every query, so I select all 5 university hospitals. Save. Close. So as I said, let's quickly select this diagnosis. So I take the shortcut because I know which ICD-10 code it is. I add the diagnosis. And now let's have a look at how do I include these 2 LOINC statements with an OR statement. And how you do this is actually, this is why you have the symbol here on the top, which is a node. So a node is always to combine different criteria. So I can now pull in this node. I need to give the node a name. So as I said, this is now a lab test for me. Say add. And then I can close it. And now, as before, I actually take my lab result and I pull it below the lab test. It opens the terminology browser. I'm searching here for my lipoprotein. Now you see we get a lot of results. So this is also something which is quite interesting. So you can already see here the kind of sum of records which we have in the system. So you can see, even though I get now 77 hits, actually most of them are not used in our context. You can also here always actually on the show concept from all to with patients actually exclude them. But I think it's very important always if you do these searches to look for which LOINC codes, for example, do we have records and are they relevant for my study? So in this case here, I have the 2, which we also had in our example, and we are interested in both. So I can do again the select concept. As I said before, I can select the second one. So I have them now here both on my list. And actually I can add them to the query. Close that one here. You can see now here that they are connected by this OR statement because I put it into this node. So they have to have the patients which we are searching for have this diagnosis, and they have a lab test, which can be either this one. Sometimes, depending on in which order you introduce the nodes, it can also happen that you have a node connected with an end statement. And if you see something like that, you can always here go on edit the node, and you can actually change set the connector from end to OR. But this really enables you to change the connectivity between the two elements. So if I go here on end, you see it's already highlighting on the left that it would change here this connection. But we want the OR, so that's why I'm not changing it. But just to, this is the way you can change it. So you can actually close it. And now, as I said, we want to set the quantity restriction. So I go on the first one on edit. So this is the moles per liter. No, this is the milligrams per liter. And this was the 130 to 180. And we can also here see this is the distribution of values. So we can already, from the curve, see that most patients actually have a quite low lipoprotein, but for our study, we are interested in people who have actually a higher value. The restriction to set, save, close. So you can see now here, I have this restriction. As I said, when I hover over it, you see the result of, or you see which kind of restriction I have set. And also I do the same for the second one, where we said this is 8 to 11 millimoles. I'm having the wrong units on the slides. Sorry for that. I think 8 to 11 nanomoles. I need to adapt the slides. Sorry for that. Speichern and close. And again, let's now search. We have 99 patients in Insel with that result. Now you see here, this is our obfuscation feature that actually these two hospitals have less than 10 patients. Some patients in Zurich with that characteristics, and we have none actually in Basel. Let's go back to my slides. So I hope I showed you how we do the AND and the OR connection. As I said, for later reference, you insert the nodes, you insert the criteria in the nodes. If for some reason you have the AND statement here, you can change it by actually editing the node and changing the set type of connector. I think that's more or less in a nutshell the main functionalities which we have. I would like to give you, like as I said, a short outlook, what is also possible, what comes next. So from the software, what is currently available in beta, which I have not shown you today, is the time dependency. So really that you can include, I want that the patient got that medication after he got a certain diagnosis. So really time dependencies between the different concepts, and also occurrences of events. So for example, you want to know people who had more than one, or let's say 3 like heart bypasses, for example. So this is also something which is possible, of currently available in beta, but will soon be also in main functionality. And I think I mentioned it before, that's why I haven't shown it. We are currently working on putting the substance amounts for the medication into the system. This is available also in beta for 4 university hospitals. And actually for Insel, we will have this enabled next month. As I said, please be aware, this is really now the first load, so there is still some maybe quality issues, which again, we are happy to receive your feedback on if you encounter something, because this is really how we can improve the system and feed this information back to the hospital. I also included you here the link to our homepage where you can find more information, additional videos on that system. And I think with that, I'm actually happy to take questions. So I think I stopped sharing my screen that I can actually open the Q&A panel and have a look at the question. Related the results given as total, but can we obtain a CSV of the result disaggregated to some major groups, for example, sex, gender, age, hospitals, disease grouping over a year, or do I have to run multiple searches to obtain these results in an disaggregated manner? I think I showed you with the funnel what you can do and with the summary statistics. So for example, you can have the summary statistics for the different hospitals. It is, however, as I said, the system is not meant for that you search. Sorry. Yeah, sorry, I first answered this question, then I read the next one. So yeah, that we actually not extracting this kind of information. I think I just heard that actually I had a very active team in the background, and that people are actually, all the questions are already answered by writing. So thank you, Katrin, for that.
You're welcome, Sabine. Thank you for the questions, all of you. So I noted down some of them, which were particular and also maybe of importance for the others. Sabine, is there a way to distinguish between emergency, for example, and non-emergency hospital admissions or treatment? So can we, group those where the patients basically entered the hospital? Is there a possibility for this?
No, there is no possibility for that. We are actually looking with the hospitals into these kind of characteristics for some of our projects. And actually, I have to say, it's a quite challenging topic for harmonization, because really what kind of different departments there are in a hospital and how they are named and grouped, this really differs a lot between hospitals. So this is a quite challenging harmonization task, but this is really something we are working on in the SPHN context. And of course, if we have things like this harmonized across the country, we could also include it in the federated query system, but currently, unfortunately, the data is not available.
Exactly. Thank you, Sabine. So this was also my answer to many of the questions, if the federated query system can be expanded with regards to this data type or that data type. So it's exactly what Sabine said, right? So as soon as the data is available in a standardized or harmonized way, the limitation should not be the system. The limitation is always the availability of data. So there is another question with regards to the lab value. So is it possible to scan for lab changes?
I'm not sure if I understand what is mean with lab changes. So what you, as I said, with this feature of the time dependency, what you could, this is now, I creating that now in my mind. You have to tell me if that must make sense for what you were looking for, that you could, for example, say, I'm looking for a patient which had a normal glucose level, and then with a time dependency, for example, 2 months after had a measurement of a high one. So that would be like a change like in this value. So yes, would be possible with this time dependency feature, which is available in beta. So please take it with a grain of salt, but I think it's quite stable already.
Thank you, Sabine. And another lab question, how are patients with multiple lab measurements handled? So is there a possibility, for example, to distinguish between routine lab measurements and those required by a physician?
for us, all the lab measurements are equal. So as I said, they are all coded in LOINC. For example, if you know which lab measurements were taken as part of the routine lab, you can of course add them, as I said, with an AND or connection to your query, but there is no additional metadata in which context. Also, if there was a normal panel measured and then the clinician said, I need to know this parameter again, it was remeasured, that would be all similar. This is also.
Okay, so if there are currently no new questions, please feel free to type. I will read some of the old ones in order to bring it to the attention of everybody, and maybe also for you to correct my answer, Sabine. If, as far as to my knowledge, only inpatients are included, is that correct?
Mostly. We have some hospitals which have also outpatients included, but again, this is our current limitation is really if the coded data is available. And so some hospitals really start now also heavily on coding of outpatients data. This is included. Also, what we have seen is, of course, that asking people for consent is more challenging for the outpatients. That's why I would really say it's most probably 90 to 10% inpatients to outpatient, but there is outpatients in there.
Okay, and the residency of the patients does not play a role, right? It could also be people coming cross-border for commute and so on. So that doesn't play a role, right?
Exactly.
Okay. Also, is the ICD-10 diagnosis the FOPH diagnosis that we have here? So it comes from billing?
It comes from billing.
Exclusively?
Again, there is some activities in some hospital to also, as I said, also, for example, for outpatients to start coding. These ones are included as well. But as I said, I would say, again, here also 95% is the diagnosis from billing. But there can be additional ones which we have coded in the hospitals. And of course, the aim would be as soon as we have more coded diagnoses in the hospital, also maybe with other standards, again, that this would be included, but it's currently really a data availability question.
Okay, thank you. Then there was a non-technical question regarding the ethics approval needs. So I already answered this. So when you want to do queries, this is not necessary to ask ethics approval for queries since it's only aggregated patient counts that are disclosed to you as a researcher. And this aggregated, in this case, truly anonymized data does not fall under the Human Research Act, neither under the Data Protection Act, and does not need ethics approval. However, we asked, of course, if the system itself, if this provisioning of the data to researchers for doing feasibility, if this needs ethics approval. And also here we received a waiver from the Ethikkommission Nordwest und Zentralschweiz, I think it was, that we contacted. So since the system is not able to basically calculate, to do analysis on the data, we are, as Sabine showed to you, we are able to obfuscate the results, right? So everything smaller than 10 is not disclosed. This is, of course, not possible if you do calculations on the data. And with this obfuscation, the possibility to drilling down to an individuum is basically impossible unless you commit fraud and run 1,000 queries after the other, which we will, of course, recognize at the back end, and which you say that you are not doing this while signing the acceptable use policy. So in this case, you do not need ethics approval. We have two new questions. Can the population be filtered in age groups?
Yes, so you can actually not even on age group, but really on over 17 or over 65. So in this kind of search, you can really go to the single years of an age group. And as I showed you for the results, you also get this aggregated statistics with the age groups to give you a bit more information on your population than only having its 500 patients. But you have these histograms, which are because of obfuscation reasons in the age groups. And also here that you cannot drill down to the single patient.
Thank you, Sabine. And then there was a question, a new one, but also related to an old one that I already answered, is the question, do researchers have a way to get the data after doing the feasibility? And of course, why else would feasibility make sense if you cannot? So researchers can already now receive data from university hospitals, but of course, this is this needs the compliance with the required preconditions. That means a data transfer and use agreement has to be established as a legal basis. And also, since then you use the data for a research project, you need to have ethics approval for this research project. Also, university hospitals have governance processes in place, and they are not the same in every hospital. This is basically in the hands of the hospital to regulate the governance processes. And of course, these also need to be complied with. But in general, if you now detect a cohort that you would like to use for a research project, the process would be that you get in contact. We have on SPHN's homepage all of the detailed contact information of the 5 university hospitals for these kind of requests. And you can submit a request in terms of also get in contact and get more detailed information from the 5 hospitals on the data set potentially available. But then you would have to go through the normal cycle of preparing documents and getting approval for that. Any other questions?
I posted the link to the page which Katrin mentioned in the chat. So on the right, you can see contact OSZ, contact Insel, contact SCHÜF. So that's the contact points, or the contact. Often it's an institutional email which you can contact.
So we have thank you, Sabine, another new question. Not all clinics use electronic health records. How do you deal with these data? Is there any option to link these data with those from the platform? Not sure if I understand the question correctly. So we are working with the 5 university hospitals. You're asking for the clinics within the hospitals. So as we showed at the very beginning, at the introduction, we only can fill data into the FQS from the clinical data platforms of the hospitals. So whenever a primary system of a clinic is not collected or connected to this clinical data warehouse of a university hospital, the data will also not be mirrored in the query system. And also here, there are individual solutions for all 5 hospitals. Of course, not all 5 hospitals have the same primary systems connected to their platforms. If you want to know what exactly which clinics are connected in which hospital, you have to refer to the address that Sabine just pasted in the chat and ask the individual hospitals, because this is also not known to us. Okay. Any other questions? Sabine, is there something that you also wanted to add?
No, I think, or maybe only, I think, try the system out. In case you encounter any problems or issues, please feel free to reach out to me, or in general to the DCC address, and we will try to help you. And I think also, if you have any feedback on additional functionality which you would like to see, or also encounter any data quality issues, I think that's a big topic also from my side. How can we improve the data quality? And again, the data quality in that system is reflecting the ones in the clinical data warehouses. So again, we try to go at the source with improving quality, which also makes it a quite slow process. But of course, we are very happy to, if you spot something, to get that information so that we can actually act on it.
Yeah. Also, one thing that we would like to motivate you for is, if you think other things need to be included urgently into the system, right? We said that the limitation is the availability, but of course we can talk to hospitals, we can jointly work on solutions that would enable harmonized data for the one or the other data type. or, for example, a more general information, and this is basically on our internal list, I just disclose this here because I think it's not a confidential information, would be if a biosample potentially is available of this the cohort that you now found through that query, yes or no, and what kind of biosample. So think in this direction when you use the system, what additional information would be of value to the researchers, and please feed it back to us so that we can work on further expansion of the system. This is one new question that just came in. Does the system consider individuals with multiple follow-ups? For example, if they had a stroke in 18 and another one in 20, is there a way to know that the 2020 is a second event and the same individual? Also, same is true for the lab tests. If the same person gets a lab test every day, would that not overestimate the number of unique people with a certain condition?
There's several questions in it. As of first, I think if we search for the patient, as I said, if one patient has like 4 strokes, the system will only count still this one patient, because it's really the one patient having the 4 strokes. With, again, this time dependency and the occurrence feature, which, as I said, is in beta, you could search for these things. For example, that you say, I want people who have 2 strokes, and then you would find the one which had the 2018 and 2020 stroke. Also with the time dependency, you could, for example, say that these events have to be at least 1 year apart from each other. So I think this is really one of the new functionalities, which I think you can do a lot, but I think you would really need to try it out from the logic, as I said, occurrences, time dependency, and/or connection. So this is the kind of basic features which you have, and you can, of course, combine them in all crazy ways, which I think gives you a lot of possibilities for these kind of questions. Again, the records have to be there. So, for example, if the stroke was recorded at a different hospital, then, of course, this information is, of course, lost. That's maybe also something which is very important. So it's always like this patient in this hospital, because we have, as you may all know, we have no way in Switzerland at the moment to really link patients across hospitals.
Okay, if there are no additional questions, you can, of course, also always, as Sabine said, email to the dcc@sib.swiss if you have additional questions, and or reach out directly to Sabine. We will put the slides, Sabine, right? And also the recording. The recording will be made accessible on our SPHN YouTube channel, but we will also put the slides and the information somewhere on our website. Let's say it right now so that we don't have to send it.
We have a Git repository. Actually,
okay.
I can. And actually, this is linked, as we have a website page where we will have all the information that will link to the Git repository. So for those who know our Git repository for the other trainings, this is where you can find all the slides and all the training materials, but it will be linked from the website. And also we will send a follow-up where we say the video is now available on YouTube with the different information. But we try to put everywhere the kind of links where to go. Let me see if I would need to log in with second factor to the Git before finding the right link. So sorry for that.
Okay, so we can send it to you. We have your email addresses and we can pack a package and send you the information afterwards. If there are no additional questions, thank you very much for your attendance. Thank you, Sabine, for putting all of this together. And luckily the live demo worked, which is always nicer than something recorded. So we are grateful.
And I have the Git link. I pasted it in the chat, but very good. Also send it.
Good. Thanks a lot, everybody. Have a nice day. Thanks for your interest.
Thanks a lot.
Bye-bye.
Bye.